So let's say you're not as comfortable doing them straight off the periodic chart. We want to double check, right? We want to be able to do it multiple ways, kind of thing, right? It's an important idea. We also want to be able to analyze it and know what it's telling us. So if we want to do the electron configuration for iodine, right? Not a bad idea to pause me and just try and do that. I've got 53 electrons to put out. So I'll just start here, and that's going to be 1s2. That's a garbage marker. 1s, I don't want to do orbital notation. I want to do electron configuration. So 1s2. From there, we would go to 2s, 2s2, 2p6, 3s2. From there, we'd go to 3p, 3p6. Anytime you end in a p in one of the p6s, that's a noble gas. So you can always do noble gas configuration where you can say, just like this, because this is 3p, so that's the third energy level. The third energy level down is argon, right? I don't have a periodic chart handy. So third energy level down is argon. So you would say, well, the inner electrons are just like argon, and then from there, and then we do whatever, right? So from 3p, we go to 4s. And this is where it starts to get kind of confusing when we get down here to the bigger ones. So we are at 20 electrons right now, so we need way more. So then we get to the 3ds, 3d10, so that's 30. From 3d, you go to 4p, 4p6. So there's your valence electrons right there. So this is what the electron configuration for krypton would look like. So if you're doing something just a bit bigger than krypton, you could certainly do it that route. Like iodine will happen before the next one. So if we want to do noble gas configuration, we would say just like krypton and then add on the rest of this stuff, right? So from 4p, it goes to 5s, 5s2. I should have written some more of this out. So then we go to 4d. You can fit 10 in the d's. Notice the d's will always be one less than the s's that come right before them. So you had 4s and then 3d, 5s and then 4d, 10. So we had 30 right here. So this is 36, 38, and 48. So we have 5 left. So from 40, you will go to 5p. And we had 5 there, so 5p5. So my valence electrons, see if you can spot them. My valence electrons are my highest energy level S and P electrons. So we have 7 valence electrons there, right? So these electrons are out a little ways, right? So they're not held on as tightly as some of them are, because we saw with Coulomb's law, the further you go out energy-wise, the less you can hold on to those electrons. But this has 53 protons too, so that's a stronger force pulling on those. And you've got 7 valence electrons. So iodine's going to be small for its period, but it would certainly be bigger than other things in its group, right? Because it's kind of far down, but it's way over to the right. So it's shrinking a little bit. And so it will hold on to its electrons pretty well. And it would even want to go get one more electron because it's got 7 valence electrons. If it gets one more, it would be stable. So this would be the electron configuration for iodine. If I did iodide, right, if I gave it a -1 charge, called it iodide, now we'd have one more electron, so we'd go 5p6 right there, right? So iodine in compounds, right, is iodide, and that would have a -1 charge. This is iodine, the element, right? And if I want to do the noble gas configuration, I'd say just like krypton, 5s2, 4d10, 5p5, right? Because these are really the ones that are the most important. So if we say all the inner electrons just like krypton, then you can just kind of focus on the outside ones.